In this video, I'll be showing you how to solve absolute value equation. We're going to be using the method of graphing, okay? So here is an example of absolute value equation. You have absolute value of x minus 2 is set equal to another absolute value function, negative absolute value of x plus 1 plus 5. So we are looking for x values that will plug into the left side and the right side that will make both sides equal. So we're looking for some x value that we're going to put in here, like in here and then in here, that will make both sides of the equation equal. All right, so to solve it by graphing, what you need to do is to graph both equations, okay? Both sides separately, but on the same graph paper. I have graphed both of them ahead of time. So this is the right side in black. This right side of the left side of the equation. That is absolute value of x minus 2. That's the one I just highlighted in yellow. And the left side is the one in red, the one I'm highlighting in blue here. That's the right side. As you can see from the graph, that those two graphs are intersecting in one location. Two places rather. The first location is right on the left side over here. Right here. This point. And if you trace the x value for that, you get x equals to 2. And the right side of the intersection is at x equals 3. So the solution to this equation is x equals 2, negative 2 rather, and s equals 3. Okay, so what I have not done is to show you how I graph those two. I want to review how to graph those functions, but basically, if you know how to graph an absolute value equation, all you need to look for is the intersection. The x values at the intersection. That's all, and then that's the answer, okay? But just to back up a little bit on how to graph those two functions, I will erase there and graph them from the scratch. Okay, so if I want to graph the left side, I want to write it as y equals. If I want to graph that, y equals absolute value of x minus 2, I know this is a shift 2 to the right and no shift up and down. So it's saying there's a shift 2 to the right. And then there's nothing here. There's no y shift. So that means the vertex for this is going to be at 2, 0. So my first step is to locate 2, 0. So which I'm going to locate over there at 2, 0. Let's see if it's writing. Okay, so it's 2, 0. All right. So after locating a vertex, the next thing I will do is I will go one step to the right of the vertex. I could also go to the left, but the right is a little bit more convenient. So I go to the right. The next value, the next x value after 2 is 3. So x equals 3. What I want to do with that is I want to plug that into the equation. So it will be y equals 3 minus 2. That's 3. And then I evaluate that. Absolute value of 3 minus 2 is 3 minus 2 is 1. And the answer is 1. So when s equals 3, y equals 1. So there's a new location, so it will be 3, 1. So I can go one step to the right will take me to 1 right there. And now I know that absolute value actually has line of symmetry, all right, that passes through the vertex. So I'm trying to draw that, right? So using that line of symmetry, if there's a point at 3, 1, there must be a point at 1, 1. So now I can continue with this pattern because I see there that I'm going 1 to the right, 1 up, 1 to the right, 1 up, one to the left, one up. So I can actually draw this graph. I draw this graph now using those few points. In reality, I just need only 2 points to make a line. Let's see, that's not working. Okay, back again to graphing. Okay, here we go, it works. So I can draw that absolute value function like that. Okay, I have drawn the first one. What I want to do is to draw the second one now. So I go through the same process. Y equals negative x plus 1 plus 5. Now, using my transformation knowledge, I know that this is going to be shifting 1 to the left and 5 up. The parent function is shifting 1 to the left and 5 up. So the vertex is going to be located at 1 and negative 1, comma 5. So if I go negative 1, comma 5, I put a point there, negative 1, comma 5. That will be somewhere over here. All right, negative 1, comma 5. So now what I need to do is I need to go one step to the right of negative 1. That will be a 0. So if I go one step to that, to the right of negative 1 will be 0. So I want to plug that in. So it will be 0, that's a negative on the outside, 0 plus 1 plus 5. Don't forget the negative on the outside. So there will be negative, and then absolute value of 1 plus 5, which is going to be negative 1 plus 5, because absolute value of 1 is 1. So negative 1 plus 5, which is 4. So I know for sure then that the point 0, 4 is on that graph. It's on that second graph, 0, 4. So I'm going to go ahead and put 0, 4, which is right over there in red, 0, 4. Again, there is a line of symmetry right there. I can use that to graph the other point on the other side of the symmetry. So now I have 2 points, and I know it's just, the pattern will continue. So one right, one down, one left, one down, and so on. And I can just make this graph now. If I continue that pattern, it's going to go like that. Now I can make this graph. Let me quickly make it so it look like this. All right, something like that, and then like that. Okay, now so I have made the 2 graphs. Now that was what I showed you at the beginning of the video, and now I can look for the intersection of those 2 graphs. So I see one point right here. I trace it to the x value, and that x value right here is the solution. Let me kind of put a block around it. That's the solution to the equation. And the other intersection is right here, and that's the other solution.